Welcome to another tutorial, and today we're going to discuss how to change controller targets in UPBGE. So you're going to learn how to use the controller. We're going to control a player, and then I'm going to show you how to switch the target of the controller to another object like a pause menu or something like that, but it'll probably just be another object in the scene, and then we'll go from there. All right, so here we go. All right, first we got the default blend file up, and we'll go one. I'll go and raise this a little bit, shrink it down by pressing S. We press G to move it around, and then we'll leave that there for now. Then we're going to go Shift A, add new mesh plane, scale that out. We've seen this before in a lot of other tutorials, haven't we? And actually, we're going to make this more of a side scroller game, so we'll actually get rid of that. We'll delete that. Press X delete. We're going to do add mesh cube, and that looks good. We're going to scale it on the x-axis, so S and X, scale it out. Then we'll scale everything in a little bit, make it smaller overall. There, something like that. And then, good deal. All right, and we'll go to rendered view. We're going to change the background of our world color to more of a blue color, raise it up a little bit. Good. We're going to change our light to a sun, so we're going to click on the light, go to light properties here. So it's going to lower it to 5 and set it to sun. And now it's nice and bright. That's a little too bright. Let's do 2. Something like that. And we'll go that way. It's not going to change anything, and then we'll re-rotate it. I'll do lighting something like that. There you go. And we should actually move this more to the front. Rotate it more. Something like that. Okay. Then we'll select our block. We'll go to the material editor. It's already got a default material on it. We're going to change its color to green for the player. And we'll set its emission to green also, and raise the emission a little bit so it lightens up against the background. Something like that. We'll make this one like do this one new material, make it orange. Go to emission, select the color, select the dropper, click the same orange, raise it up a little bit. There we go. Now everything's nice and visible. Then we're going to go ahead and copy this platform, move it on the x-axis just so we have a gap to jump. And we'll copy this player character and go on the x-axis, and we'll make this one, give this one a new material. So we'll click plus here, minus there, this new, make it purple, pinkish purple. Go to its emission, grab it same color, raise the emission so it's a little bit lighter. Okay, let's make it yellow. I'll make its emission yellow. Just up a little more. Okay, good. Now press 1, so we're on the side. Then we'll do an easy camera parenting here. So we're going to go to View, Align View, Align Active Camera to View. Press G, then Z twice, pull away. Get a little bit more center. And then we'll go ahead and parent this camera to our player object. So we're going to name this cube player. We'll name it player 0. Let's call it character 0. Character 0. Select this one here, the yellow cube over here. We're going to call it character 1. And this platform, we're going to change this name to platform 001. Select this cube and call it platform 002. Oh, we have to put the dot in there. Then next, light can be light, camera can be camera. Select the camera. First, we're going to select the character, then we're going to control click the camera. Now, select the camera first, control click the character. So we got a dark orange on the camera, a light orange on the character here. And then we're going to go to Object, Parent, Object. In this green player object, we're going to go to the Physics tab on the side here, change it from static to character. And we'll go to this object 2 and change it to character. This yellow guy over here. That guy. All right. And we haven't scripted anything yet, but if we press play, the camera's going to drop with this player character, right? So press play. And yeah, it drops. The camera moves with the player, so that's fine. Cheap camera rigging. All right. Let's go ahead and we don't want to scale. Yeah, that should be fine. Okay. All right. So our goal for this tutorial is basically to use the controller to move the player around, and then when we get next to this character and when we get next to this little yellow guy, when you press the Y button, the control will switch from the green character to the yellow character. And we'll have to make the camera jump to that too. And actually, that's going to take some scripting probably. So that'll be interesting. All right. Give me a second. Okay, so the first thing we got to do is we have to move this character around. So we're going to need 2 classes. First, let me bring in BGE. So go here, import BGE. And we got to save this Python file. So save, write, in the toots folder. And this will be tutorial 17.blend. I thought I only did 12 last time, but I guess I've done 16 of these so far, and this is going to be 17. So this is going to be pi. And actually, we should call this, yeah, it's fine, toots, and we'll call this, control switcher. Let's just call it control.py. Okay. Okay, it's a Python file. We got our formatting, the linter's working, and we should have some autocomplete now. So we'll do class. So we're going to need two Python components. So we're going to need one called game controller, because I'm so original. And it'll inherit from bge.types.kx Python component. My linter text is getting in the way. So expand this window for a sec just to make sure. Okay, we'll do that. Not. Okay, then we need our args equal to empty dictionary for now. And just leave that for now. We'll do class. Second one we're going to need is class player mover. UPBGE.types.kx Python component. Args equal to that. Okay, we got our two components started here. So the way it's going to work is the game controller, we're going to do something called property injection, where rather than have the controller, like when, the analog stick is greater than a certain area, move the player left or right. Instead, what it's going to do is it's going to send a property as a signal. It's something I haven't covered before, but you can use properties as signals to the object, and we can basically look in. Every object has a dictionary attached, right? That's just there's two versions. There's attrodict, and then there's just the general object dictionary of KX game object. To be quick, we'll use that one, but if you want speed and performance, you should probably be using attrodict, but I don't care right now, so we won't be doing that. So I can't teach you everything. All right, so next we're going to do our start function here. And as usual, we're going to need an isActive set to bool, a boolean. And then anything else for now? No. And this one needs an isActive. That'll also be a bool. Okay. All right, so in our start function, we need to bring in our two character objects. So self.car1 will be equal to self.object.scene.objects. Character 0. Oh, this should be car 0, huh? There we go. And then self.char1 will be equal to self.object. Character 1. Just gonna move this over. Need room for my linter to give me keep my linter from going over the code. All right. Good deal. And then that should be it. Let's go ahead and create our update. Do a pass. Player mover for now, we'll do def start. Do a pass. And def update. Do a pass. Save our code. And we need to open our code and bring it in. Open control.py. Save it. Go back to here. Do a write. It says we can't write it because Blender wrote to it, and we gotta do an exclamation point. There we go. Reload it. All right, we're good there. Then basically, as we go through our code, we want to play it and just see we have no errors, which means let's go ahead and attach this to our player, to our two characters. So we'll attach add component. We'll do ctrl dot game controller. It added without error. We didn't get an error, so it's good. Well, the next one, control dot player mover. Good deal. Doesn't matter is active isn't being used yet. It doesn't matter to check, but they came in without error. We could press play and we'll save it. Save this blend file as toots, and this will be tutorial 17.blend. I actually feel a little more productive now. Okay. Next, we press play, and we shouldn't get any errors. No errors, just tells us the game controller warning. But I'm using a Game Seer controller. All right, good. Let's get this bigger so you can see more. Let me play it. All right, next, we need to add our controller function. So some interesting ways to do this. So what we can do is just like with Python, there's a million different ways to do it. But we'll do call this control axis. Self, and it's going to take in a control target. And it needs to be of type BG dot types dot JX game object. So this is what we call type inferencing. We create a variable and then we point it to a type. So when we set this variable to self.object.scene.object.character, this variable here becomes a type KX game object. And so this control target will check to make sure that it's a game object. And if it's not, it will give us an error when we try to run it. So that's the way we can perform type checking and make sure that the argument coming in is of the correct type. So making sure it's an actual object in the game, like character 0. So do that, and then Another rule is basically you want to set what the type inferenced output will be from this function. Since we're removing the objects and not returning a data type, this will be type none. So you use this shove operator, or this I don't know if it's called a shove, but it's basically the output of the function operator, and it returns none. So this is good because it's self-documenting. It tells other people working on your code that this doesn't return anything. It just does something in game. So this would be the same as doing void in like a C# function, right? So type output is type none, and then all right. So what we're gonna do is what I used to do is I used to create a variable called x, and it would be equal to bge.logic dot uh, bg.logic dot joysticks 0 dot axis value 0. I used to do that, but I found out, I don't know if it's a bug or not, but basically, when you use axis value 0 here, if your control axis code gets way too long, the Python garbage collector will actually end up deleting chunks of the code that use this AX variable, and so what will happen is if you try to do analog stick down, um, it won't give you the full value. It'll give you like negative 0.01 on the axis, and that's no good. So instead, we're just going to use this the whole time. So we'll do, and actually we have to go ahead and print the output. We're going to do a pass here real first and not call the function. And what we're going to do is we're going to print bge.logic.joysticks 0. Uh, BGE can support up to 8 game controllers, so this can go 0 to 7 here. So we're going to do 0, and then dot axis values. So we're going to print this, and this is going to give us a what we call a read-only list. So when I move the game controller, we'll see what's going on. So I'm going to turn on my controller, make sure it's connected. Oh, my game sphere is connected. I'm using my Python controller. Okay, game sphere. Yeah, when you're making a game, you buy different controllers to make sure that all the buttons are consistent. So sometimes buttons are different on Windows, but I don't care about Windows. So let's get this bigger here. There we go. Okay. All right. So this is going to print this. So we're going to save this. Oh, get caps on. All right. Then we're going to do Alt. Alt R to reload our script so far. When I press play, we're going to see down here at the bottom, we got this list now. And when I move the left analog stick to the right, we see that that's list value 1 or 0. So left analog stick to the right is -1. Left analog stick to the left is +1. To the left, it's -1. To the right, it's +1. Then when I go up, we don't quite hit 1 with our joystick, but it's close to 1. -1 when we go up, and when we go down. Okay, it goes to +1. Okay, yeah. You have to get it at the right angle. So -1 is up, +1 on list item. The second field here, that's our up axis. This is our left-right axis over here. The right joystick is value number 2 on the list, or the third position in the list, right here. Up and down is the fourth position on the list. And then our 2 triggers should be, let's move this over. Our 2 triggers should be list value 5, or list value, let's see here, 0, 1, 2, 3. List value 4 is our left trigger, and list value 5 is our right trigger. And those only go between 0 and 1 because they're triggers. They're not axis, they're not analog sticks. So, okay. So we'll stop this. Good. So what we're concerned about is game axis 0 and game axis 1. 0. This is 0 here. This is 0. This is 1. So we'll go ahead and put this in. So, and what we're going to do is property injection to our control target. So, if bge.logic.joysticks 0.axis values 0. So we have to add a dead zone to our component, so we'll do that up here. So this will be dead zone. That's going to be equal to a float. Okay. And then we got to assign that to a variable. So self dot dead zone is equal to oh, I should go ahead and put them up here. So we'll do X, Control D. Okay, so that's going to be equal to args dead zone. I'm trying to be fast because there's this is going to be a bigger tutorial, so hopefully y'all can follow along. Is active is equal to args is active. Okay. Good. So now we need to do a property injection into the control target. So we're going to do if BGE axis value 0 is greater than self.dead zone is less than negative. We're starting with going left, so less than negative self.dead zone. We're going to say, so this is where I did this wrong. I attached these components to the player when they need to be attached to an empty that's off to the side because we're changing controller targets. So let's create an empty over here. Shift A to add an object, add empty, and then we'll go and move it off to the side here. And we're going to call this empty, we'll call it geo control for global control. Sure. And then we'll attach these components to it. So add player mover. Well, player mover is going to be added to the players actually, but we'll add controller to this empty. So add control.game controller. This empty. And then each of these will get player mover. So add control. Did I call it player mover or character mover? I did call it player. We'll call it player mover because the player changes to different characters. Okay. Player mover is active. He can do it. Yes, I can. All right. No, I don't talk to myself, I swear. That's why I'm doing this YouTube channel, so I can have a reason to talk to myself. All right. Moving on. Okay. We're going to go ahead and put a pass here for a second. And what we need to do next, actually, is we need to go ahead and import from enum, import enum. Okay. And what we need to do is we need to create an enum class to select our two characters from. So this will be a list that will let us switch between one character and another. So I'm going to do class car selector. Let's call it car select, and it'll inherit from enum. And we're going to do character. Let's do car underscore one. Or car, we got a 0 and 1. So car 0 is equal to 0. Car underscore 1 is equal to 1. Got our enum made. And then and what we actually want to do is we want to make these names match so we don't have to type as much. So let's go ahead and do this. Character 0 is equal to 0. Character 1 is equal to 1. There we go. All right. Next, we're going to continue with our control access function here. So next, actually, I'm going to show you why we need this enum. So if we go to update, we're going to print that enum. So if we print, first we have to declare the enum. So we'll say self.controlTarget. Yeah, we're going to do CTL target just so it's different than this. Just so we'll say C target is equal to car select dot character 0. So when we start the game, it's going to start with character 0. And then what we're going to do is we're going to print self.cTarget, and you'll see what it outputs. And I'll comment that out. And we'll put this pass back here for now. All right, good. So when we print that cTarget, we print that enum. Oh, I have to reload the. I have to reload the empty here. Now it has a dead zone in it. Okay. And we'll play again. Okay. So we'll see the value here of car select is character 0, right? It'll say car select.character 0. So this is the string output of printing our enum. So and because we've done that, we actually don't need these two lines anymore. So I'm going to delete them. There we go. Okay, so control axis is going to be, all right, so let's go ahead and continue on with this. So now, let's go and continue with this enum. So because this enum is giving us a string output, what we can do is we can apply string formatting functions to it. So what we can do is self.cTarget dot, we could make it a string. And then what we want to do is we want to get rid of car select here. So we can count the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I believe that's 10 or 11. So what we can do now is we can make that a string and then do dot. So the first thing we're going to do is, we'll do we'll do 10. Oh, we have to do a range. So up to 10. And we'll print that and see how far we get. So this is string slicing. So we're string slicing to get this to match. We're trying to basically make the string match the name of our object here, up here. Right now, this is not fully capped. This is fully capped. And then also, we got this extra set of characters on the front. So we're going to do Alt Reload, press play. Okay, so we got car select there. So we need to start at 10 and go from 10 to the end, or 11 to the end, because we need that dot to disappear too. So we'll change this to 11 to the end. And now when we print it, I will save this, reload, And now when we play it, you'll see down here now it says character 0. So we're pretty close to what the name of our object is with this enum. So the next thing we're going to do is we're going to do self.cTarget, and then we're going to do dot, oh, oops. Dot capitalize. So what we have these different string formatting options when you do a string. You have capitalize, which basically makes it the first character is capitalized, the rest are lowercase. You have case fold, which I don't use. These are format. You have count, which counts the number of characters. Let's see here. There's lower, which makes everything lowercase. And there's also an upper that makes every character uppercase, but this is already all uppercase. So the one we want is capitalized. So we'll do dot capitalize. There we go. And now when we print it, character 0. Good. Okay. So now that we got the formatting figured out, what we can actually do now is we could change cTarget. We'll leave cTarget this way because we want to be able to switch this enum, right? So we'll add some logic that changes the character, right? So it changes which character we control. So right now it's set to character 0. If we wanted to change it to character 1, we could do character 1 right there. But right now it's 0. Okay. Okay, the string formatting's correct. We'll leave that here so you can copy and paste it later. All right, back to the controller. So if bg.logic.joystick0.x0 is less than negative dead zone, what we're going to say is this control target here, control target dot control target, and then we're going to add we'll call it AX LFT for AX left is equal to none. We just need a value. It could be any value, it could be none, it could be true, false. We're going to choose none. Control axis is equal to, I'll make it easy for you guys so you're not worrying about it. So, alright, let's just call it none. It's fine. None's just a value we need. It's 16 bits. It just takes up, it gives us a value to assign AX LFT. Okay. Then we'll copy all this again. Yank. We're yanking it. And we'll do paste, 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 paste. Okay. Then we're going to add some else's here. So else if XLFT is in control target del control target XLFT. So what this is doing is when we move the joystick all the way to the left, it'll say it'll add the property axis left to the control target object. And then if the joystick axis is not pushed to the left beyond the dead zone, it'll remove this property from that object dictionary. Okay. So actually, I'm going to delete all these and then copy this all. So delete, and then we'll copy this. Ink. And we'll paste it 4 times. I probably did that one too many. Let's undo that once. There we go. Okay. All right. So then if axis 0 is greater than positive dead zone, I'm going to put axis right in there. And then else delete axis right from the object. And we'll work on axis 1, which is our up and down axis. So we know negative is up. So if it's less than the dead zone, then we'll do AX up. And then if it's greater than positive, if 1 is greater than positive dead zone, we'll do AX down. And AX down. And AX down. Okay. So we've got our axis function finished here for the left analog stick, and that's all we're going to use today. So that's done. And then we can go ahead and write a test to make sure it works. So we'll do test obj control. And then basically that test is going to be print. Oh, we could put control target in here again. So self, and then control target. And it has to be of type BGE dot types dot kx game object. And then that'll just be print control target dot property, get property names. All right, next, we're going to go ahead and use this function. And so what we want to do is we'll put in our axis function to test for the controller, and then we'll put in our test object control function to test that the controller is working on the player on character 0. So what we'll do first is we're going to do self dot control axis. Okay. Control axis, and then our control object is going to be a string. Oh, we should make it a string. No, we want kx game object. Okay. So this is going to be a little bit of fancy function. So it's going to be self.object.scene.objects. That's going to be string. It's going to be the same as the thing down here. So string self.cTarget character up to 11 dot capitalize. It's the same as what we did here for the test here. And then we'll do self dot test object control. And we're going to grab this. Shoot. Okay. Select this text. Yank it. Go in here. And paste it. There we go. Good deal. All right, so when this runs, we're gonna go ahead and comment this out. So X, Shift, Control C. There you go. That's commented out. All right, so it's going to send, when we move the controller, it's going to send these properties to character 1. And then and we'll go ahead and make this test a little bit more descriptive. So we'll say print target plus control target dot name. And then here we'll do properties plus control target get property names. Okay. So now we'll see if our controller is actually sending control signals, these properties to this object. They'll show up in this test. They'll say what the target is, which should be character 0, and then it'll say what properties are in that object. And when I move the controller, they should switch between axe left, axe right, axe up, axe down. Okay. Sorry if this one's technical for you guys today, but I'm getting tired of, holding y'all's hand, right? So you birds need to learn to fly. You got to leave the nest, right? Okay. All right, so we saved it. And we'll reload it. And we'll play it. And we got some errors here. Car select key not in list. What did I do wrong? Okay. Oh, I printed up to 11. I need to go 11 past, so I got my formatting wrong here. So these need to be 11 colon. So if you're following along, I'm sorry for my mistakes, but there we go. So that's our error. Reload. And now if we play, we should have our test running. Oh. Oh, so we got to turn the string into a list. Okay. So this needs to be, we could do text formatting for it. So we'll just convert the string. It's faster. Yeah. There we go. That converts our read-only list of properties into a string. You need one more of those? Yep. There we go. Okay. All right. Now we'll try it again. And play. All right, good. So our target, it says our target is character 0 and our properties. Now if I move the controller to left, okay, something's wrong because it's giving us 2 properties. Why is that? Oh, I know why, because our dead zone is set to 0. So if I go to our control object here, we got to raise our dead zone. So let's do 0.5. There we go. Because everything was greater than our dead zone, right? So now we'll do it. Press play. Now if I move the controller to the left, axis left, to the right, X right is in our properties. Press up, X up is in our properties. Press down, X down. So our test is running down here. So look down here at the print output, right? X up, X down, X left, X right. Okay, so our controller's working right. And this GL control empty is sending these properties to this character right here. Okay. All right. So we've done that. So now we need to make a character move. So let's do that because we'll add the switching between the 2 character functionality later. And in fact, I'm not going to waste time with the jump. You could look up how to make things jump in the documents, and there's other tutorials out there that tell you how to jump, and I think I even have a jump in my other tutorials, so you can go find it. So we'll go ahead and move this a little bit this way, and then we'll scale them the X. There we go. And we'll watch it from out here to make sure that the characters fall. Damn, yeah, they both fall. Good. Okay. Good deal. They both have the character physics on it. All right. Okay, let's start making these move. So next we're going to we should go ahead and use isActive here first. So if self.isActive, there you go. And then here we'll do start. We'll do self.isActive is equal to args isActive. Okay. Next, we need to create our movement functions. So we want to add a character speed value to the component so we can change the speed in the GUI in UPBGE. And so we're going to do speed. That's going to be of type float. And self.spid is equal to args speed. Good. And then create a function called move character, move char self. And this will also output to none because we're not returning a value. If we're doing some pre-formatting stuff here, right, we do like, if we wanted to return an integer, this shove, after this type inference operator or shove operator, I don't know why I call it shove. It must be a functional crap. It's not shove, it's just point. The return type, it's the return type operator. So return type operator is none, and that's going to be the case whenever you're not returning a value. So if there's no return in your function, the output type should be none from that operator. Okay. And the reason I do this is because actually other game engines like Godot require this, right? So it's a way to prevent, like changing types in your functions on the output. So sometimes you want to mutate types for convenience, but it's not usually a good idea. All right, so next we're going to do our if statement. So what it's going to check is if these properties that we had earlier, let's see if we have any up here. Yeah. No, it doesn't because we didn't. Okay. We know our types though, that if these properties acts left, so we're just basically checking if they exist. So if AX left in self.object, self.object dot do you want to use the player physics? Do I use the walk direction physics, or do I want to just change the position? Let's do delta time and change the position. So we're going to create a global function right here. So we're going to do def delta time self. Oh, no self, it's just delta time. And then it's going to probably return a float, but we'll leave it open. Now let's return a float. And then average FPS is equal to bg.logic.get average frame rate. And then FPS is equal to bge.logic dot get logic tick rate. And then return if 0 else return 1, else 1.0. There you go. I think I did that right, but I'm going to pause for a second, look up my other delta time functions, make sure that's correct order. Because sometimes I've switched these two and it really fucks up the game. So give me a second. All right, I'm back, and yeah, it looks like I did this one right. We don't need this. There we go. Then our global function, we're going to set a variable called dt, set equal to delta time. But we're not going to call the function. We're not going to put that. It's just going to have dt loaded in memory and ready to go. It'll be running this calculation, but only run it while we're using it. Okay. All right. So if ax left in self.object, we will move self.object dot world position dot x. So we're moving on the x-axis. Minus equals self.speed times dt, and do it. And then we'll copy this and do this. We're only interested in left and right. I only did up and down so you know how to do it for the controllers. You can use it for another type of game. So we only care about left and right in this player mover today. And then, all right, our move function's done. So if ax left, if the string ax left is in the properties of the object, then we'll decrease its world position by the speed value times delta time. If right is in it, we'll increase it by the speed times delta time. And that'll make it move left and right. And then we need to add our else's. Else self dot oh no, the else's are built in. It won't do anything. So we'll stop. And we'll test that. Okay. And then self.move character. Okay, so this will detect what we're doing. When it detects we move the controller and these properties are put in the object, when this component detects that these properties, AX LFT and AX left and AX right, are inside the object's properties, it'll move the character one way or the other. It'll move them left or it'll move them right. And so we'll save that. Question is, will it stop when it's not in there? We'll find out. Okay, moving right. Nothing's happening. Okay, let's go ahead and make this object move over here so we can see if it's moving. Oh, we haven't added the speed yet, have we? We need to reload this. There we go. And we have to add the speed. So speed will be 0.4. This one reload. Speed will be 0.4. Oh wow, that's really fast. Okay. So because our float, I mean, we could do 0.04. Yeah, we'll just do that 0.04. It's because you should really also the physics get wonky when the objects are this small, so it's really a good idea to make your objects and your environment a lot bigger than the initial default because you want the scale of these to actually be over like 1 meter in order for the bullet physics to work right. Because once things get smaller, the bullet physics can be a little wonky, but it should be fine for this. But just know, make your colliders, your environments, and your models bigger than you think they should be. That way, the physics engine doesn't go crazy on you. Okay, it's still pretty fast. So, oh, because we have to change this 1.04. Okay. All right, now we'll try. There we go. Yeah. Axe left. You'll see axe left is inside the object. Axe right is right. Good. So far our components are working as expected. So now what we want to do is we want to add a button. We're going to use the Y button or the triangle button on the controller, and what it's going to do is it's going to change this enum from character 0 to character 1, and then it'll do the other object, right? So we'll do that. The only issue is the camera. I'd have to do some research to make it switch the camera between one or the other, but we could do a quick camera tracking, I guess. How much time are we at right now? I wish OBS told us the recording time, but it doesn't. Oh, it does. Okay, it's already been an hour and 14 minutes, so this is getting pretty long. So we'll just, what I'll do is I'm actually going to unparent the camera from this object and move the camera farther away, and then you can see it switch between controlling the two objects. So we'll select our camera and then do Control P. No, is it Alt P? Alt P, clear path. There we go. And we'll move the camera on the x-axis so both are in. And we'll zoom out a bit. There we go. So now you see the two objects. All right. Because our goal is to change the control target from the green character to the yellow character. All right. So now what we're going to do is we're going to create a buttons function in our game controller component. So we're going to create a function that's going to be we'll call it control buttons, control BTNs. It'll accept self, and then it'll have the control target, and it'll be of type bge.types.kx game object. And it's also going to return none. This will also return none. Just because it's good practice. Okay, and then control buttons will be we're going to go ahead and do pass, and then down here we're going to do another print test. So I'm going to comment out our test object control for now. So X and comment out, and then what we're going to do is we're going to do print bge.logic joysticks 0 dot active buttons. And what this will do is this will print what button is active when I press it. And what I'm interested in is the Y button. So we'll go ahead and save this. And then how to turn on my air conditioner. It's hot as hell in Texas right now. All right. So it'll print our active buttons, and so we'll press play. And it's printing what we call read-only list. If I press the little Y button, you'll see that button 3, like X is button 2, A is button 0, B is button 1. We're interested in button 3, so that's what we want. So go ahead and close that. All right, and we only want it when we press the button. We're going to do an on release. So when we release the Y button, it'll work. So what we can do is do well, first we'll do our if statement. So if 3 in bge.logic.joystick0 dot active buttons pass for a sec. So what we need to do is we need to create a component wide variable. So we'll do a comment here. This is player target. And then we're going to do button state integers. And we're going to say self dot we'll go ahead and call it button Y. Or we'll just call it button state. Button state is equal to 0 for unpressed. So it's self.3, then we'll do self.button state is equal to 1. Else nothing happens. So else self.button state is equal to 0. Next part we need is let's look here. If the button is active and self.button state is equal to 0, set the button state equal to 1. Now the reason we do this is so the button has to be released before it'll turn to 1. And then that part's good. Plus equal 1. No, no, we just want 1. It's equal to 1. And then we'll go ahead and add we'll add our logic in a second. And then else if 3 in BGE.logic.joysticks 0.active buttons. And so we're doing on release, right? So on button release. So elif. So we'll do this. Elif self dot. Yeah, this should be fine. And self dot button state is equal to 1. Ooh. Then and button state is equal to 1. Then we do our code. So we'll do control target. So this will do it on press. So yeah, so control target. Oh no, we need to change the enums. So self dot c target. So we have to add the logic. So if self dot c target is equal to what do I call it? Car select. Okay. It's equal to car select or char select dot character 0, then self dot c target is equal to char select dot character 1 elif self dot c target is equal to character 1. Dot c target is equal to char select character 0. So we don't need this in here. This just runs. Yeah. Almost done with this. Oh. So we'll do this on release. It'll be easier. So not in. If the LF3 not in, no, no, in. We want it in. So when we press it, it'll only do it once. And then at the end, yeah, you press it down, it goes to 1. Yeah, so when we release not in, and the button state is 1, it does all this. And then after that's done, I'm trying to figure out how I'm going to create it. Yeah, if I'm holding it down, it'll stay held down and not 1 until it releases. And then once it releases, it turns back to 0. Okay, good. So then at the end of this, we do self.button state is equal to 0. Yeah. So once we release the button, it'll run this code and then set the button state back to 0. So we actually have to, yeah, we have to press it multiple times more. If we hold it down, yeah, it won't work until we release the Y button. That's good. Okay. All right, good. Now, because we swapped the enums, we don't have to change any of the other functions down here. So let's go ahead and clear that out. Uncomment this. There we go. Okay. And we'll save it, reload it. Let's make this bigger now. I think we got this. Left, right, left, right. And then if I press the Y button, let go. It's not changing it. Okay. Let's try that. Oh, we need an else. Let's do an elif. We're going to go ahead and add a print. Yeah, we'll add that to this one. Okay, it's not changing the variable. Let's try printing self.button state. Make sure the button is. Oh, I know why, because I'm not running the function. Oh, God, that's so dumb. Okay. So I'm get rid of that, get that back in there. And then we need to add the buttons. So self.control buttons. There we go. You have to run the function if you want to use it, don't you? All right, next. Left, right, then I press and release the Y button. Left, right. Look at that. Press the Y button. Left, right. Press the Y button. Left, right. So you can see here, you could actually map this to the pause button, right? And then you can, when you press the pause button, it makes the menu become visible and then changes the control target to the menu, right? So then you can change the state of your menu. But here we're just doing it between two objects, character 1 and character 0. So Right, you can make a puzzle platformer this way where you have to switch between multiple characters in a game to open up different doors, right? So everything's working. All right, so that's the tutorial, but we're going to go over our components now. They're pretty big this time. Sorry, this is a longer tutorial, but these things take work unless you want to vibe code them, and vibe coding is shit. Companies created vibe coding just so they could fire their senior programmers and hire new people. So AI is a lie and way too expensive. All right. So next, so first we have our character select enum that have the same names, but they're all capitalized as our two objects here, right? We have a delta time function that gets the average frame rate and the current log. It gets the average frame rate, the current logic tick rate, and returns FPS divided by the average FPS if the average FPS is not super high. Otherwise, if the FPS is super high, it'll return 1.0. Then we got that global delta time function mapped to a DT variable, but it's not executed until we run it in our code. All right, next. Our game controller component has a float called dead zone. It's assigned here. We create a variable called character target or C target that points to the first enum in our enum at the top here, the character select enum. Then we have our button state integer that determines whether the button is pressed or not, button Y is pressed or not. We have our control access function. So basically it accepts a KX game object data type as its input. Then it checks the controller to see if the left analog stick is negative dead zone for left, positive dead zone for right. Axis 1, which is the up and down axis on the left analog. It's there, so you have it for your own edification, but we're not actually using it. Our control buttons function checks to see if button 3 in the joystick is pressed. If it is, it changes the button state to 1. Then this part of the else if statement checks if it's not pressed. If it is already the value of 1, then it executes this change. So this means when the Y button is released, it switches the control target from character 0 to character 1 on the enum only. And then finally, our test object. This was the test to make sure that the GL control empty was sending the properties here created in the control access function, making sure they were getting sent to the object, right? And then in our update function, we run the control buttons, and then the control access, our input type is self.object.scene, and then a string of our enum, a string formatting of our enum from characters 11 to the end. So basically, the C of this character all the way to the end of the word, right? And we use the capitalize function so it matches the name formatting of our two objects over here, the character 0, character 1, right? And that's what the changing of the enum allows the switching of what the controller is controlling, right? Then our player mover function is in both objects, and it detects if the property AX left is inside the object dictionary, and then it also checks if AX right is in there. And then if they are in here, it'll move the characters left or right. If they're absent, it'll skip and not do anything. And then that is times delta time, so regardless of the frame rate, the object will travel the same distance. And then it runs the move character in the update. And then to prove also that this works, we can look at our test output from the printout, right? And so if I press play, you'll see in our test, our target is currently character 0. And when AX left is inside the properties of that object, it moves left. When it's to the right, it moves right. When I press the Y button and let go, it changes character 1, and we now see that inside character 1 in our console output here, right? We're seeing character 1, AX left and right are now going to it, but they're not inside character 0. Press Y again, switches to character 0, and now character 0 is receiving those properties, right? And there you go. And that's how you change controller targets in UPBGE. So I hope you enjoyed this tutorial. Have fun coding, go make your games, and have a great day. Bye.